how to become a data scientist. I have divided this video into 3 sections. The first one is a story. It's all about what data scientists actually do in real projects. And then in the second section, I'm gonna show you the whole roadmap. I'm gonna walk you step by step in each tools and skills that is required to become a data scientist. And then in the third section, it is my personal recommendations and Q&A. So everything is prepared in chapters and you can pick the one that you want. And by the way, if you are new here, welcome. My name is Bara and I lead big data projects at Mercedes-Benz, from data engineering and analytics to machine learning and AI. And I explain complex concepts using my handwritten sketches. It's gonna be amazing if you support the channel by subscribing, liking, commenting. This really helps. So now let's start with the first topic. What are data scientists? What do they actually do in companies? So grab a coffee and it's story time. Alright, now the story with the data always starts with a problem in the business. So we have a business question like, for example, how many customers do we have in the last quarter? Now, of course, it is a smart thing to ask the data instead of having gut feelings about the problem. That's why we try to get the answer from the data, and for that we hire the data analyst. So now the data analyst is going to open their tools and start pulling the data from different sources, maybe from the sales system, customers database, and product logs. And of course, they are in between many steps, but at the end, the data analyst is building a report, a dashboard, using BI tools like Power BI or Tableau. And of course, using visuals, it is always easier to deliver the message, the story behind the data for the business users. And now, once everything is ready, the data analyst is gonna go and present the result for the business users. But now this is gonna scare everyone. The trends is going down, we are losing customers in the last 3 months, and everyone starts to panic. And now what's gonna happen? Of course, one of the managers gonna ask a very important question. Can we predict how many customers are going to leave in the future? So which customers are likely to leave so that we can take an action maybe in order to prevent that. And now if the managers go and ask the data analyst about the predictions, highly likely you will get an answer like this. Well, I have only Power BI. I can only show you the data for the current situation or the history, but I can't make something very intelligent in order to predict things in the future. And my friends, exactly for this scenario, as we get more complicated and advanced questions, we need a data expert, a data specialist in order to solve this problem. And here comes the data scientist. So that means if the business question is all about the current situation or maybe the past and the history, then we need a data analyst in order to do something called descriptive analysis. But now if the question is looking to the future, then we need a data scientist in order to do predictive analysis. And of course, this type of analysis, it is way more complex than the descriptive analysis, and for that we need like an intelligence system. Using tools like Power BI, Tableau, SQL will not really help. So now let's see how our friend the data scientist gonna solve this problem. Now of course, for each problem we need always data. That's why the first step is to collect the data. But now this time the data scientist needs way more data than the data analyst. So anything the company is generating about the customers gonna be important in this phase. So the data gonna get extracted from databases, logs, spreadsheets. So everything that is related to this issue gonna be collected in one place. So now of course all those sources speaks different languages and they structure and store their data differently. So that means the data stinks, the data is chaotic, and it's time to get hands dirty. So that means in this phase we are doing data preparations, or let's say like pre-processing. Like for example, we can go and merge those files together and the sources using joins, and we have to check the content of the data. If there are a lot of nulls, we can go and replace them with something more meaningful. And another thing that we can do is that we can correct the data types, maybe remove the duplicates. Maybe there are like columns that are totally useless. Now this step is really time consuming, like you spend 70 time of your total projects only doing those stuff, only cleaning and preparing the data for the next steps. And of course, if you are lucky and have a data engineer like me in your project, then we're gonna go and prepare all those stuff for the data scientist, so that the data scientist only focus on the next steps. But you don't have this luxury in each company. That's why mostly you will end up doing those stuff. Alright, so with that we have now a perfect data set that is clean, structured, and ready for the next steps. And now you might get excited and say, yes, now we're gonna go and do some magic, some AI and machine learning, right? Well, I have to stop you there. Before we touch anything about machine learning, we have to do something very important. We have to explore and understand the data. So we have to do something called exploratory data analysis. So what we're gonna do, we're gonna go and open our notebooks and start asking questions, like for example, how the data is distributed, how we can cluster the customers, is there like any outliers, what are the relationship between like different measures. So with that, you are exploring and understand the content of the data, and this is something that we will not go and share with the stakeholders. This step we do it for us, the data scientist, in order to understand the data. It's like doctors, they read the charts before doing any diagnosis, right? So it's like a thinking phase. You look at the data, ask questions, and make notes. So friends, as you can see, things are getting really interesting, right? And the thing behind me is getting bigger and bigger, you see? It is like hugging me all the time. How sweet, right? So now, the sponsor of this video is Datacamp. Thank you for that. If you are serious about becoming a data scientist, Datacamp could make a huge difference in your learning journey. What I love about it, how you can start as an absolute beginner, no coding experience is needed, and step by step master the skills and the tools that you actually gonna use in the job, like statistics, data manipulation, R, Python, you name it. Their associate data scientist in Python track is super practical. You will learn how to manipulate data using pandas and how to create beautiful visualizations using Matplotlib and Seaborn, and work in real projects and then deep dive into machine learning. And the best part, everything is interactive. You are not just watching a tutorial, you practice directly in your browser, and when you're ready, Datacamp can get you officially certified as a data scientist. And now things get better. Datacamp has partnered with Microsoft to offer 50% discounts on Microsoft certifications exams for learners who complete relevant tracks on Datacamp. So you are getting the best of two worlds: hands-on experience and a direct path to industry-recognized certifications, and all for half of the price. Now, I have been recommending Datacamp for a while. If you want a clear and structured roadmap to become a data scientist and earn employers' trust, check the link below. It is what I wished I had when I started out. So now, let's go back to our story. Alright my friends, so now once we have a good feeling about the data and we feel confident, we can understand the data, we can move to the next step. And the next one is very powerful, but yet very underrated. Sadly, a lot of data scientists skip this. Now, the scenario is like this. The dataset that we have is, yes, clean, prepared, but the data itself, it is very raw. It is not yet like an information. Like for example, you could have a column called the sign up date of the customer. Now this is very raw. Instead, we can make like an extra column. We can derive a new column and we calculate the days since the sign up. So that means we are creating new columns. We are deriving informations from the raw data, and we can create other measures, like for example, the total spent by customers, the average session duration. So we are deriving smart columns that don't exist on the original dataset. And of course, they are not easy to create. You need some domain and business knowledge. That's why we have done the EDA phase, right? And this is very important. I really don't get it why some skip this phase. The quality of the features that you add to the dataset gonna decide really the outcomes of your work. So this is what we mean with the feature engineering. We are deriving important informations from our raw datasets. And now, my friends, with that, we have everything. We are ready and it is magic time. So it is time to do some machine learning. So now the first step is that we're gonna go and split our datasets into two sets. The first one is the training set, where our model gonna learn from. And the second one is a smaller one, the test set. We're gonna use it in order to test the performance, the output of our model, because if you train and test at the same datasets, basically you are cheating. So we don't do that. We split the datasets, and now the next step is the most important one. We have to choose an algorithm. An algorithm, it's like a set of mathematical steps that describes how to learn from data. So basically this is completely mathematics, and what we have to do is that to understand those algorithms, because we have many different algorithms and we have to pick the right one for the right problem. So now once you pick this algorithm, the next step is that to go and apply the training datasets on the algorithm. So now we are combining mathematics with data. So the algorithm gonna go through all your data and start learning from the datasets. And this is what we call, my friend, training a model. Now that means the model gonna start learning the patterns. It's gonna go and find connections and relationships between the data, and it's gonna start adjusting itself as well to minimize the errors. So that at the end we get something very powerful called a trained model that we could use in order to do predictions for new data. Now the output of this trained model gonna be predictions. So it could be like, yes, the customer is likely to stay, or no, this customer might leave soon. So we are labeling each customer, or we could have like percentage on how likely the customer gonna leave. Now, of course, we have to share now this knowledge to the business users. What we could do, we could import everything, the data and the predictions in Power BI or Tableau, and build again like a visual in order to show the final results. So as you can see, it's always a nice thing to communicate with the business users using BI tools because they are very friendly compared to maybe like visual inside your notebook. So now we go and present the results for the business users, and now they have more understanding what could happen in the future. Now next what's gonna happen, they're gonna plan actions. So maybe they're gonna go and launch retention campaign, or maybe send new offers to the risky customers, or maybe the sales team gonna go and reach them directly. And this is the most beautiful moment as a data scientist. You see, you are adding value to the company. You are not just building like a fancy model because you could. You are really helping the business to see what is coming and to do something about it. Now, this sounds like an happy end, right? You have delivered your work, you have improved the business, and that's it. But sadly, the bad news is that we are not done yet. So far, everything that we have done is manually, and as well, like we can call it prototyping. But now, of course, this is not one-time activity. We have to continue doing those stuff, and you cannot keep doing everything like manually on your notebook. And of course, the sources keep generating new data every day, and maybe they are useful informations that you have to train the model again. So now we are at a point where we have to automate everything and make deployments. Deployment means we take everything that we have done manually so far and put it in real automated system. This system, of course, should not run locally at your notebook. We have to run it on servers, for example, in the cloud. And of course, what we can do, we can use APIs in order to connect internal applications and system in the company to the model in order to show those scores at the front end. So the whole thing is all about to bring everything that you have done manually at your notebook and to deploy it to professional platform that is fully automated, scalable, highly available and secure, and connectable to different applications at your business. And if you are lucky enough and you have ML engineers or ML ops, they have to do those stuff. So as a data scientist, actually, this is not the thing that we do, but if you don't have them, then you have to do it on your own. So now, my friends, everything that you have just shown, like collecting the data, preparing the data, training the model, this is what we call classical machine learning process. Because we are now in 2025 and we have entered the world of pre-trained models, especially the LLMs, large language models like GPT, Cloud, Mistral, and others. They are models that already trained on massive amount of data in the internet, on public data like text, website, documents, and they already understand language, context, and reasoning. And this is really crazy because before we have like models and we have always to train the models, but now everything is prepared for you. We have models and as well they are pre-trained with massive amount of data. But now you might say, yeah, okay, those pre-trained models are really good, but they are very like generic. They trained on the public data. In the companies, we have like special data. Well, it's fine because most of those models, they allow something called fine-tuning. So that means you can go and pick one of those pre-trained models and train it, fine-tune it with the company's data. And with that, you make it smart with your domain, with your business. And now you might ask, okay, why we need all those LLMs? Well, think about it like this. If each time the stakeholder or manager need like a new report or new informations from the model, and you go and jump and get the data from the model, put it in Power BI and then present it for the stakeholders, this is really slow. So instead what we can do, we let the user have a chat with the model, and the users could start conversations like, for example, why are customers leaving a region B? Summarize all the feedback from the cancelled users. So they're gonna have like a chat with the model, and this is way better than waiting each time for your Power BI reports. And for that, we could use the help of those pre-trained models, the LLMs. And now, of course, comes the scary part where you ask, if we have all those pre-trained models, why do we have even data scientists? I understood from you we need data scientists in order to train models. But if we have pre-trained models, why do we need them? Well, first of all, my friends, everything that I have described is the industrial data scientist. So someone is hired in the company to do those stuff. But the one that pre-trained those data models, they are as well data scientists. But they are not hired from the industry. They are actually researchers. And of course, they work in massive engineering teams in big tech companies like OpenAI, Google, Meta, and they do the amazing work of bringing those pre-trained models in the market. And from the other side, of course, we still need the industrial data science for one very important reason. Well, my friends, all those LLMs and pre-trained models, they are trained on public data. And most of the companies, they don't bring the data on public. They all internal, confidential, and even secret. So there will be a lot of business problems that depends on the company's data. And as long as the companies protect their data, we're gonna end up in this situation where we need to hire data scientists in the industry so that they either fine-tune the pre-trained models, or in many scenarios, they have to train from the scratch the models using the company's data. And that's why the data scientist in the industry is very relevant. And to be honest, we have now a lot of work to do because we suddenly exposed to all those pre-trained models and we have to fine-tune a lot of new models. So I am very positive and excited about it that this can accelerate our work. This can open the door for many use cases that I never thought before. And believe me, we have a lot of work to do. So now back to our story. Now we come to the last thing that we know so far. We have something called AI agents. So now we are far beyond having a quick conversation between the business user and your model. Now the user is gonna ask for many stuff. Like, for example, how many customers did left last year? So what we can do, we can have like one AI agent that is using pre-trained model to convert this text into an SQL query that goes directly to the database and grab the data. And of course, show it at the end as visualizations. And another thing the customer might ask, for example, where I find the customer's data in which system, in which application. So for this scenario, we can use another AI agent that could use as well pre-trained model that's specialized on scanning documents. So this time we don't need the company's data, we need the documentations of the company. And now if the customers ask something about the future, how many customers gonna leave next year, then you can use an AI agent that connects to our model that we trained from the scratch, that we are very proud of. So if you look to this, we're gonna have a lot of AI agents that are connecting to different models, connecting to different data and sources. So of course we have to orchestrate all those stuff and connect everything. And that's why we're gonna have like a manager AI agent, the top level agent that's gonna get the prompts from the users and decide which agents and models are involved and then respond back to the users or do an action, like for example sending an email. Whew. Well, that might be a lot of information for some of you. I can keep going and adding stuff to this big picture, but it is not fitting anymore. So now I'm gonna say take a break, drink water, some coffee, and then we continue, right? Well, I have to be careful with this one here. So now, let's go. Okay friends, so now what we're gonna do, I'm gonna show you the whole roadmap step by step. All the skills that you need in order to become a data scientist. Alright, so now let's start with the first thing. You need to learn mathematics and statistics. Now, of course, the question is, why do we need them? If you have a look again to our big picture, you need statistics as we are exploring the data, for example. If you know statistics, it's gonna help you to understand and to read the data. Like, for example, calculate the average, to understand how the data is spread out, how to find the correlations of two variables, and as well we need the statistics for the feature engineering. Maybe you want to do some aggregations, rolling average, running totals, some kind of normalizations. Those are all based on the statistical thinking, and if you don't like extract powerful features, you will end up having inaccurate results from your model. So as you can see, having solid statistics gonna help you in two major phases in your process. Now, talking about the scary part, the math. Well, first of all, we need math at this phase where we are picking the model, the algorithm, and training the model. So the thing is, you don't need to be like a big expert or a math genius in order to train a model. So my friends, that means the statistics part is way more important than math. And now, my friends, what I'm gonna do, I'm gonna show you exactly how deep you need to go for each skill, for each tool as a data scientist. And here I'm gonna split it into three categories. The first one is the first contact. So it's all about to get yourself familiar with the concepts or maybe the tool and to read or maybe work with it like for 3-4 hours. It's all about to have a feeling about it and as well some awareness. The second category is all about the basics. So here you have to cover the fundamentals, the basic concepts, and do some exercises and practice with the tool. And at the end, you have to do like 1 to 2 small projects. And the third level is advanced, where you go deeper in the skill. So you have to have some understanding of the complex topics. You have to practice a lot. and as well understand what are the best practices, tips and tricks. And at the end, you have to pick like some advanced projects. So now what we're gonna do, I'm gonna show you always what you have to learn in the first year learning data science, and as well what you could learn in the second year, or let's say if you want to get yourself as an expert in data science. So now for statistics, you have to have some basic understanding of the summarizations like median and mean, and as well about distribution, the correlations between two variables, and as well probabilities and data sampling. And now for math as well, some basic understanding about linear algebra, calculus, vectors, optimizations, so only the basics about math. So now to the next skill, we have to learn about the programming languages, my friends. So now by looking back to our process, we need, for example, SQL, because we need it as we are collecting the data from the sources. You have to select the data in order to extract it, because most of the data are stored inside databases and we have to talk to the databases. And as well, we need SQL in order to prepare the data, to join the tables, maybe filter the data and so on. And as well, we need SQL as we are deriving those features. So you need SQL as a data scientist. And now we come to the most important programming language. You need to learn Python. Well, I can say for each step, actually, you can use Python in the collection, preparations, the explorations, feature engineering, of course, training the models. It is, my friends, involved in each of those steps, and you have to have really solid foundations about Python. And a third programming language, we could use R in the exploration phase, actually in the ADA. Well, R is amazing in order to do statistical analysis, and where else you could use it in order to maybe analyze the output of your model. But I'm gonna say Python is way more important than R in your process. And the fourth thing that, my friends, you have to learn about GitHub. Of course, our process is including a lot of coding, and you have to store it somewhere to have versioning. You want to share it and collaborate with the others, so you have to learn the basics about Git and GitHub. So now I'm gonna say in the first year, learn the basics about SQL, Python and GitHub, and in the second year, go deeper in Python, SQL and GitHub, and if it's needed, learn the basics about R. So this is all about the programming languages. Okay, so now let's keep going. The next group we're gonna learn about data processing. It's all about how to learn to manipulate the data, to transform the data. So if you are looking again to our big picture, we have to learn more tools and skills to do the first two steps, the collection step and the preparations. And for this, we're going to use the help of the Python libraries. For example, the most important one, pandas, where you can use the powerful data frames where you store the data inside it and do quick data filtering, sorting, aggregations, merging the data, handling the nulls, and so on. And the second library that you have to learn is the NumPy. It is very powerful for the numeric values to work with the arrays, vectors, metrics, and many stuff. And the third library that you could learn here is the PySpark. Once you are getting massive amount of data from the sources, pandas will not be enough. You have to switch to PySpark in order to manipulate and prepare large datasets. So now for the first year, I'm gonna say deep dive into pandas and learn the basics of NumPy. And in the next year, I'm gonna say learn the basics of PySpark in order to be ready to process big data. Okay, so now what is next? We're gonna go and build skills about data visualizations. This is very important in order to understand the numbers and the data. Okay, so now let's have a look to our process. Where do we need data visualizations? Well, in the EDA, as we are exploring the data, we use here visuals. And since this is only for us, we don't have to go and use some fancy BI tools. It is enough to have visualizations as we are coding. We don't have to go and use an extra tool for it. And here we have three main libraries. Either we use Plotly or Matplotlib, or we could use the Seaborn. So although three are Python libraries, you could use it in order to visual your data. Now, if you are looking to our process, we have another place where we use data visualizations as you are presenting the results for the managers. And here, please don't go and open notebooks and show the visuals for the managers, because it is not that modern, and you're gonna get better effect if you show the visuals in Tableau or Power BI. And here you don't have to be an expert and pixel perfect in Power BI and Tableau. It's really enough to have like very simple and basic report and dashboard. So again, if you are doing visuals only for yourself, use the Python libraries, but if you are presenting it for business users, it's nicer if you use Power BI or Tableau. So now in the first year, I'm gonna say, go and have a first contact of all 3 libraries. And I'm gonna say, pick the one that you really feel like comfortable using it and go and learn the basics about it. But for me, I like Plotly compared to the others. I feel it's like more interactive and modern. And about Tableau and Power BI, just pick one of them and learn the basics. And now, of course, you're gonna ask, should I learn Tableau or Power BI or both of them? Well, don't learn both of them. Just pick the one that your company is working with. But if you can choose, I'm gonna say, go with Tableau. It is more advanced and more easier for you as a data scientist than Power BI. Power BI is good for standard dashboarding and reporting that the data analyst and the BI developer usually do for like massive amount of users. And now about the second year, I'm gonna say pick one of those 3 libraries and go deeper, but you don't have to go deeper with Tableau or Power BI. Alright, so now so far all what we have learned, it's all about how to collect, prepare, and analyze the data. Well, it's gonna make you a data analyst, but not yet a data scientist. If you want to become a data scientist, you have to go beyond analyzing the data. Okay, so now the first topic is gonna be about machine learning. So we have to learn the classical ML, and we start first with the theory. The theory could be split into 2 sections, supervised and unsupervised learning. So supervised learning means we give the data together with the correct answers, with the labels. So that means the model knows already the answers and try to connect the dots and learn from it. And after that, we give it the real data and the model should predict based on what it learned. But with the other hand, in the unsupervised learning, we give only the training data without labels. So we don't give the correct answers and the model should train on its own in order to uncover hidden patterns. So we don't give the correct answers, the labels, and the model should figure out on its own. So here we have to learn some algorithms like the linear regression, decision trees, and random forests. And here we have to learn a few algorithms like the k-means and the PCA. So now if you look to our process, you have to learn those stuff in order to pick the correct algorithm and model for the business issue. Without this, you're gonna pick one blindly and you will get bad results. Now, after the theory, we have to learn about the tools. This is the interesting part. And again, we have to learn Python libraries. So here we have libraries like the scikit-learn is very powerful and as well easy to use. And here you're gonna find the classical stuff. You're gonna find models about classifications, regressions, clustering. So this is a must to learn. And we have another powerful libraries like the XGBoost, the LightGBM, one that is developed by Microsoft and it is optimized for large datasets. So if you are dealing with big data and you care about the speed, then you have to use the LightGBM. So now my recommendation for the first year to deep dive into the scikit-learn and have a first contact with the LightGBM and the XGBoost. In the next year, of course, you can go and learn the basics about those 2 libraries. Now, after that, my friends, you have to go and start doing ML projects. This is very important in order to understand why we are doing those stuff, how it looks like in real world. So I'm gonna say in the first year, do a project like the sales forecasting or go and build a recommendation system. Then the next year, you can go and do some advanced projects like the fraud detections and customers predictions and classifications. Of course, there are a lot of ideas and projects and pick the one that you like. All what you have to do in this phase is to do ML projects. So with that, you covered the classical machine learning and we can say you are already a data scientist. Now, before we go to the advanced stuff, we have to learn about something called deployments. So here you have to learn the basics about deployments, how to build a training pipeline, how to save the model, retrain the model, how to load it with fresh data, and how to do as well CI/CD. And for those as well, we have tools that you could learn on the first year, the Streamlit and the MLflow. Just learn the basics and in the next year you can go advanced with those 2 tools. So with that, not only you are prototyping, you can as well bring things to real environments. And now after that, we want to get you to the advanced topics in data science and you start learning about the deep learning. It is a subset of machine learning that you could use in order to learn complex patterns from large amount of text, raw images, videos. Using a neural network, it's like brain made of code. So that means first you have to learn the theory and the concepts, like what is a neural networks, CNN.
This is CNN Breaking News.
I'm talking about CNN of image processing, and as well RNN for sequences like text. Well, you don't have to memorize all those stuff, you just have to have some basic understanding. Now, of course, after you cover the theory, we have to go and learn the tools. So here again, we have Python libraries, and I'm gonna say for the first year, go and learn the basics about the PyTorch. PyTorch is developed by Meta, Facebook, and it is very flexible, friendly, and easy to use. And another deep learning framework, which is developed by Google, you can learn the TensorFlow. It is really amazing one that is used in the Google Translate, YouTube recommendations, and many amazing real-world applications. So I'm gonna say for the first year, get the first contact of those libraries, or even the basics, and then the next year go deeper, and as well you could have the first contact about Keras. So those are advanced things about data science. Okay everyone, now moving on to the next one. It's all about having some coffee. Let's have some coffee, right? Now, the next one is interesting and modern skill that everyone is talking about. We have to learn about the LLMs and genai. Now, as you learned, we don't have always to train models from the scratch. We have now the pre-trained models that we could use for many amazing stuff like chatting with data or searching in documents. So it is now really in trend, and it's gonna be amazing if you have this skill. So now what you're gonna do, as usual, we start with learning the theory and the concepts, like for example, the prompting, embedding, RAG, NLP foundations, and after that you start learning as well the basics about tools like the LangChain, the Llama index, and as well the Hugging Faces. Now after you learn the tools, maybe you're gonna go and start doing some projects, like try to build very simple chat with documents, maybe some PDFs, and after that you could do something advanced like text to SQL in order to have a chat with data. And of course this is only the beginning, there will be a lot of new pre-trained models, you have to keep track on the trends and always try to make like a project in order to understand how things works. So if you do that, it's gonna be a big plus as a data scientist. And now the last thing that we could like add to our plan is to go and learn some of the platforms, because actually you're gonna spend a lot of time in the project if you got hired working with the platforms like Azure, AWS, Databricks. So I'm gonna say for the first year, go pick cloud platform either like Azure or AWS, and as well try out Databricks. All those platforms provide certifications, and this is really amazing for your resume. And you're gonna see this almost in each job description that they are asking for some skills in cloud platforms. Okay friends, so this is everything. This is the whole roadmap step by step, from the basic stuff like the math and statistics until we talked about the LLMs and genai. And of course, as usual, in the link below you can find the Notion roadmap on how to become a data scientist. There you can find more details, all the skills, and you can use it as well as a planner. And as well you will find there important links and resources in order to become one. Now of course, after we went through the whole roadmap, you might still have some questions. I will not leave you like this. Now I'm gonna go and tell you some recommendations, tips, and what I think about this role. So let's go. Now, there is like not only one path on how to become a data scientist. This really depends on the situation that you are on. So you could be a student who would like to be a data scientist, or you are already having a job and working with data like a data engineer and data analyst, and you would like to go and switch to become a data scientist. Or maybe you are at the business side and you would like to become a data scientist. And of course, there are many different other scenarios, but those are the famous patterns. So now let's talk about it one by one. If you are a student, maybe at university, the greatest advantage here that you have time, you have access to professors and doctors, and you will get, of course, enough materials for the theoretical parts. But your weakness, you don't have any real-world experience. You are strong at the theory, but maybe not at the practical parts. And the materials that you are getting, it is way more focused on the researcher data scientist and not the industrial data scientist. So now my advice for you, don't worry about the theory part in the roadmap, you will get it anyway. And the one thing that you want to focus on, doing projects. Go do like at least 3-4 projects. Go join the Kaggle community and try to do challenges. But anyway, you have enough time. Try to overcome the weakness by doing projects. So now we come to the person, to the data engineer or the data analyst. You have it really easy. So now by looking to the map, you are already halfway. You have already a lot of experience about the data. You know how to work with SQL, Python, how to do data processing, manipulations, data visualizations, maybe missing 1 or 2 libraries, but you have covered half of the way. And what is left, if of course the left part, you have to start covering theory about the machine learning and learn the Python ML libraries, how to do deployments. And even if you are talking about platform, maybe you are already working in Azure, AWS and Databricks. So you have it easy here. You have only to gain few skills and then you can say I am a data scientist. Now we come to the third person, the self-learning, the career switcher. You come from completely different background, like maybe marketing, sales, finance, teaching, healthcare, or wherever you come from. And here you have one major advantage compared to the others. You have already domain knowledge. This is something a lot of people wish to have, to know about how the finance works, how the sales, maybe the health system. All those domain knowledge, many people struggle to understand and to learn. And I can tell you one thing. For the world of the data analytics, it's always the one that comes with domain knowledge wins at the end, because they understand the pain points, they understand the business processes, and they can bring better and accurate solutions than the one that comes from IT. So I hope that I have motivated you, but the weakness here, you don't have coding skills. And if you are self-learning, relying on online courses and stuff, it's gonna be really easy to get lost. So that means you have to go through all the phases from the scratch, one by one, until you are ready to switch. So as you can see, friends, there is like not one path to become a data scientist. Each one of you has a scenario and you might have different experience and different shortcuts. Okay, so now we come to the big question, how to learn all those stuff. Now I thought about it, like how I'm gonna do it if I have to start over. I'm gonna do it exactly like this. The first thing that I'm gonna do, I will not learn two things together. So I will not go and learn SQL and at the same time Python. I'm gonna do it one after another. And now the second advice is that, maybe because I am very curious, I'm gonna go and just like explore stuff. So I'm gonna go and install one library and check like one example code, maybe using ChatGPT, just to understand, okay, if I hear pandas, I know what this means. The third thing, my process is gonna be like this. I'm gonna learn some theory about one topic. I will not go deep dives on it, only the basic concepts. And then after that, I'm gonna go and install this tool and just practice. It's gonna be messy, it's gonna be a lot of mistakes, but who cares? But the thing is, I will not waste a lot of time. I will just like do the basics. And then after that, I will go and make a case study, or let's say a project, where I grab some data and go through the project phases one by one, as I am like working in any company. After the project is done, now very important, I will publish everything in Git repository. I will format it, make it clean, add comments to it, add some context about the project. So with that, I'm building my portfolio. It is the evidence that I can do stuff. Because for me, to be honest, the portfolio is way more important than certifications. And after that, I'm gonna say, it's time to show off, right? So what we're gonna do, we're gonna go to LinkedIn, make a link to the project in the Git repository, say a few words about it, what are the challenges, and what I have learned about it. So this is how I would do it if I have to start over again, not only for data scientists, for any other skills. And now I'm pretty sure someone gonna tell me, you know what, Para, thank you so much for the whole roadmap, but there are a lot of skills, I don't have the time for it. I just want to learn 5 skills in order to become a data scientist. Okay, so now if you want only 5 skills, then first you have to learn SQL. It will not work without it. The data are in databases and you have to query that. The second one is Python, because it is the foundations for anything else. Then you have to learn how to do data manipulations. So you have to learn about pandas, and you have to learn about the data visualizations. So you have to pick one of the libraries. I'm gonna say go with Plotly. And the last one, you need machine learning tool. So for that, scikit-learn. So I'm gonna say if you learn those 5 skills, then you could do, of course, data science work. So I hope you're happy. Okay, so now I'm gonna give you quickly my honest opinion about the 3 data roles: data engineer, data analyst, and data scientist. So now each company, if they are serious about working with data, they need the data engineers. If they really don't have a solid data engineers, then they will waste time of everyone, because if each data analyst has to do data engineering, it's going to be very costly for the company. That's why data engineering is the foundations to do any data analytics. And lately, a lot of companies did understood how important are the data engineers. So you need data engineers in order to bring the data from the sources and put it in one platform where the data is prepared and ready for analysis and AI. Now we come about the data analyst and the data scientist. We have to be honest here. Most of the questions that comes from the business, they are analytical questions that could be solved easily using a data analyst. So most of them are really not complicated. So it's all questions about the history and as well the current situation. And I see most of the requirements could be easily covered using a data analyst. But now you might be sad, you say, but I want to be a data scientist, so there is like no work for them. Well, I'm gonna tell you, you have here big advantage of that. There is a massive hype about the AI now. Now everyone wants to implement AI use cases, make chatbots, and just go and check the market, the job descriptions. Everyone is asking for AI skills. Like even from data engineers, I'm saying they should know about LLMs, which is totally crazy. So there is a big hype for the data scientist role right now. So this means, my friend, the real business questions that are coming now from the users, most of them could be solved with the data analyst, but we are moving toward the AI. It is not like before. There will be a lot of use cases from the business. So that means this is gonna change. There will be a lot of use cases for AI. And of course, as a data scientist, now it's time to shine. All right, now I have got a lot of amazing questions from you about how to become a data scientist. Thank you for that. So I have picked now the top rated questions and I'm gonna go through them one by one. So now let's get started. The most highest asked question is actually, do I need a specific degree like a master or PhD to become a data scientist? Well, if you want to become a data scientist in the industry, it is not really needed. It is plus if you have like computer science degree. And I have met many data scientists that switch their career from something else to data science. But of course, if you want to become a researcher in big tech companies, you're gonna need some master and PhD. Okay, to the next question, how long it takes to become a job-ready data scientist? Well, it's really depends on how much time you are investing to become a data scientist, but I'm gonna say it's gonna take at least 1 year. And if you have already a job and you want to become a data scientist, then it's gonna take between 1 to 2 years. Now, the next question is all about, should I learn Python or R? Which one comes first? Well, of course, you have to learn Python first, and Python is way more important than R because, as you saw, in the process to become a data scientist, in each step we are doing something using Python. So make sure you are strong in Python and then learn R. To the next question, do I need SQL as a data scientist? Well, of course, my friend. As you know, the company's data are in databases, and if you don't speak the language, you cannot talk to the data at all. So it is a must, it is not optional. And now we come to the question that scares most of you. How much math do I need? Well, I know that the word scientist is gonna think, I'm applying for NASA, right? Well, actually, it's not like that. You don't have to be a math genius to become a data scientist. So you have to learn enough math to understand the algorithms and what the models are doing. So learn the basics, the linear algebra, calculus, and the probabilities. So again, you are not writing formulas from the scratch at this job. All what you have to do is to understand it and to pick the right model. Okay, moving on to the next one. And this one is interesting, it has a lot of likes. Do I need to build my own models, or is it enough to use libraries like the scikit-learn? Well, my friends, you don't have to build your own models. We are in 2025 and you don't have to reinvent the wheel. You can really go very far by just using the pre-trained models. But what is very important is to understand how those models work. It's like cooking, my friends. You don't have to go and grow your own vegetables, but you better know how to cook them. Okay, to the next one. How do I stand out from the crowd? What type of project should I build to get hired as a data scientist? Okay, so here's my advice. First step is to go and pick a business domain that you like. It's like a company that you would like to get hired. Is it about like e-commerce or healthcare? Or maybe car industry. Like me, I'm working at Mercedes-Benz and I like everything about the cars. And then you go and grab some fake dataset about this business domain and start doing projects. Like the most interesting one now is to make like some kind of chatbot, ChatGPT, about this domain, and as well to make some recommendation systems and so on. So with that, you show them that you have very important 2 types of skills. The first one is the tech. So you can use tools and languages in order to do something. And the other one, you have domain knowledge. And if you combine those two, believe me, it's going to be really hard to say no for you, and for sure you're going to stand out the crowd. Okay, to the next one. What tools and tech stack are used in real companies, small versus big? Well, I'm going to say, doesn't matter. You will end up using SQL and Python, but for small companies, they're going to have like few resources, and you're going to end up using, for example, Jupyter Hub together with Pandas and scikit-learn. But for big companies, you will get access to many tools and services that you could use in their projects. And for sure, since it's a big company, you can have a big data and you're gonna end up using PySpark instead of Pandas. And of course, you will not be building stuff locally at your notebook. Instead, you have to build things in the cloud platforms like Azure, AWS, and use tools like maybe Databricks. So with big companies comes a lot of tools, and you have to use big data tools as well. Okay, moving on to the next one. What is the difference between data analyst, data engineer, and data scientist? And which one is the right for me? Well, my friends, I will never be able to know what is right for you. You have to understand each rule and then you decide on your own. But I'm going to tell you something. If you would like to move the data from A to B, to do pipelining, to transform the data, to build a data model, then maybe data engineering is suitable for you. But on the other side, if you'd like to be close to the business, to understand the pain point there, to understand the business questions, and then start like searching in the data, trying to find answers, and go to the business users and show them the answers using nice visuals and charts, like you are telling a story, then my friends, you might think about data analysts. But from the other side, if you say, you know what, I don't like those pixel perfect dashboards and reports. I would like to make some intelligent system to like speak about the future, to predict things. So you would like really advanced stuff, then of course, data scientist is gonna be the one for you. But of course, if you are just searching for something new and you just want to secure a job to get a salary, I don't recommend you to go as a data scientist. You need to learn a lot of tools and a lot of things. Then you have the two options, data engineering and data analysts. Both of them requires only few skills in order to maybe secure a job, and they are easier than to be a data scientist. Now we come to another question that scares people. Is AI going to replace data scientists, or does it make us even more valuable? Well, there is very classic and typical answer for this question, and as well correct. AI will not replace you, but someone using AI better than you, they might replace you. And this is totally true. If you are a data scientist that only sits behind the screen and write codes and not communicating with the others, not trying to understand the pain points, not trying to understand the business, the data, of course it is easier to replace you because you are only coding and AI can do that. But if you are someone that is communicative, you are someone that is always near to the business, trying to understand the problems, always bringing solutions, and you understand the data and the processes, you always follow the trends and you understand which technologies are available, and you try to map between the technology and the business problems, all those stuff is not replaceable by AI, and you will be very valuable as a data scientist. So my friends, don't hide behind the screens, always try to understand the others, to understand the trends, and always bring those solutions to the company, and you will be a perfect data scientist. So those are the questions. If you have other questions, post it in the comments below and let's talk about it. Alright, so this is the whole journey. This is everything that I know about data science and what I think about it. If you're still here, thank you so much for that. I hope you enjoyed it. And if you are enjoying the content and the channel, support the channel by subscribing, liking, commenting. This really helps with the algorithm and as well to reach nice people like you. But if you are already supporting, thank you so much for that. Now that's it. So thank you for watching and I will see you in the next video. Bye bye.